Now my layup definition has been completed. So let me change some stack up sequence properties. I want to make it even symmetry. I want it to be 6 mm. Clicking apply, clicking OK. So this is the Python script. Everything what I have done is being stored here. This is the logger. All the steps that I have applied with respective time and date. Now update the model. You can see the thickness is being shown. Now let's close the Ansys ACP and update the setup. Setup is updated. Now let's import the metallic geometry. Import, browse. This is the flanges IGS file that we have created to the geometry. Let's make the mechanical model. We have, this is the mechanical model. Let's drop it there. Drop the geometry there. Let's go to engineering data. Structural steel is the default material. I will be keeping it here. So I will go to model, go to edit. Now after opening my model, I will just want to keep the flanges and suppress everything else. So suppress the body. I don't want it, I just want the flanges. Now I will be selecting the size. So right click on the mesh, sizing, and selecting the whole body, pressing the control button down. I will select one body, other body, click apply. Let's keep it the default size, or you can change it. So I will right click and I will generate mesh. I have not changed mesh on these bodies since I am not interested in looking at the stresses on these bodies. So it will just increase my computational power. So let's cross it, open the workbench, everything is updated. Now let's drop the static structural module. This is the static structure. Let's drop it there. And now let's drop the setup over static structure. Transfer. Now it will asking me either you want a solid composite data or shell composite data. Static structural module does support the solid composite data. However, the explicit dynamic or LS-DYNA does not support the solid composite data. We have to provide the shell geometry to it. Again, let's drop the mechanical model 2 over the model. Now let's update this one. So what is the difference between the square shape connector and a round shape connector? The square shape connector is defined whatever the geometry is being shared with the next block. As far as the round shape icon shows, it means whatever is the model or whatever is the setup, it is being transferred to the model of next module as an input. So after the update, right click, go to edit in the model. Now we are in a static structural module. You can see we have two things. If we go to geometry on plus symbol, we have mechanical model and we have ACP. Clicking on the plus symbols of the both, we have this flange and other flange. You can see there is a cross symbol on assembly. I suppressed that in the previous section. As far as the ACP is concerned, I have this solid model that I have generated in ACP, which is made from the carbon fiber unidirectional composites. The mesh is ready. I have already meshed both parts in the previous modules. Now what I want to do, I want to apply a pressure on the inside. So what I will do, I will go to section planes, and here I will click on this new section plane. I will draw a line like this. Section will be generated. Now I will be applying my boundary conditions. I will right click on the static structural module and I will apply pressure. It is asking me to select a face, so I will select a face select the inward face like this, click on apply. How much pressure I want to apply? I will be applying 5 megapascal pressure. That's it. It's going inward, normal to the face. It is defined by normal to the face. What else I can define? I can define component or vector. I will be applying the normal to the face. Now I will be applying the fixed support. I want to apply the fixed support on this face and on the other face like this. Click on apply. So that's it. Let's solve it. Solve the model. Uncheck the section. Check the section plane again. So it is solving. Building the mathematical model. You can apply some more section plane like this one. Anyway, I don't want both of them right now, or maybe one. Take some time, so let's wait. Now the model has been solved. It says I calculated all the stresses. So let's find out. Insert, let's first find out the deformation and find out the strains. Retrieve this result, and you can see the deformation is 1.2 mm. If you go to the section plane, you can see this is 1.2 mm. Can even go to probe to check what is the exact dimension at exact point for the probe where I will have to go. I will have to select this probe. So while moving all around, I can get the deflection points. What is the deflection at each element? In the next video, I will be explaining how to check the ply failures in Ansys ACP post or even in this module. So thank you.